This is a quick 5-10 minute tutorial on decision analysis using QM for Windows. Just wanted to go over some of the key concepts as well as again running QM for Windows. The problem that we'll go into is the one that's right out of the text chapter and really is the key to organizing. But generally, click on Module, go down to Decision Analysis, go to File, then New, and then go across. You can see decision tables, trees, so on and so forth. We're interested here in decision tables. To keep this short, I won't go into trees. Click on that, and we have choices. How many alternatives? The textbook goes through 3 different alternatives. It also mirrors the discussion we had in class the other day. So we have 3 alternatives, large plant, small plant, and do nothing. And 2 states of nature, a favorable versus an unfavorable market. We're maximizing for profits, and I'll click OK. Okay, this is favorable, unfavorable. Probabilities, like the text, there was a 50% probability of a favorable market and a 50% probability of an unfavorable. We could build a large plant. We could build a small, or we could do nothing. And if we build a large plant, we can make as much as 200,000. If we build a small plant, we could make as much as 100,000. And if we do nothing, 0. If we build a new plant and it's an unfavorable market, then we could lose as much as 180,000. If it's a small plant in an unfavorable market, we could lose as much as 20,000. And of course, if we do nothing, it costs us nothing. We have the basics here. Again, our probability of a favorable market 50%, unfavorable 50%, and we simply go to solve. We solve that off, and we can see our answers here. We could go to that window, and it will provide us a whole bunch of additional information. Generally, at this point, there's no need to go into that for our focus on the chapter. If we had more time, we might. What's important is what we have here, and our answers are right here at the bottom. Our expected monetary value is 40,000. Our maxim-min is 0, and our maxim-max is 200,000. Now for our expected monetary value right here, we have 40,000, and to find that, as you'll see in the text, it's simply 200,000 times 50% plus a negative 180,000 times 50% is equal to $10,000. 100,000 times 50% plus a negative 20,000 times 50% is equal to $40,000. 0 times 50% plus 0 times 50% is 0. And we simply take the highest of these values. You can see here that 40,000 is our highest, so it's our expected monetary value. With regard to maxim-min, we'll get into that a little bit later. Generally, when you look at maxim-min, you find the minimum value for each alternative. So a negative 180,000 for the small plant. The minimum is negative 20,000, and actually for both columns, the minimum is 0. And so you select the largest of these, and frankly, 0 is our largest value. So we would select 0 as our maxim-min, and our maxim-min is just finding the best of the best. And we can see that the highest value in our entire table here is $200,000. So we know that our Max and max value is 200,000. Again, this is just a real quick overview of decision tables and how you might use these for, whether it's a testing process that we'll go through or just going through and developing effective decision tables. Thank you very much.